Welcome to the Performance Around the Clock podcast. I am Professor Satchin Panda, a scientist in the field of circadian rhythm. In this podcast, I will talk to experts in many different fields about science, health, and human performance. You'll also find out why circadian rhythms is my favorite topic. I hope you enjoy the podcast and thank you for listening. Welcome to another episode of Performance Around the Clock. I'm super excited to have John Hogenesch as my guest. John is a professor at Cincinnati Children's and is also the incoming president of the Society for Research for Biological Rhythms. So this is our professional society of everybody who works on circadian rhythm, and being the president, he carries a lot of weight and steering the field in certain directions. John is famous for many things, and including his work in circadian rhythm, as well as his work on genomes, but we'll mostly focus on his work on circadian rhythms. As a disclosure, I was actually fortunate enough to be John's postdoc, so that's the time when the mentor put a lot of epigenetic mark on you, and maybe I inherited some of that mark, very positive epigenetic mark, I would say. And without taking too much time, I will dive deep into our discussion. So welcome, John.
Thanks, Sachin. It's great to be back in La Jolla, and great to see you and the rest of the San Diego crowd.
Yeah, no, we are super excited to have you here because, speaking of right time, right place, right team, you and I were actually at the right time in the right place and right time in the history too, when the genomes were coming out.
That's right.
And, I remember in the old days, you got into circadian rhythm through your interest in dioxin receptor. So can you tell me a little bit about what are dioxins, what are the toxins, and why they are important for studying them?
Yeah, so there's the aryl hydrocarbon receptor, which binds endogenous ligands in your body that look they're planar aromatic compounds in it, and when they bind those compounds, they activate metabolizing enzymes that help clear them.
So dioxins are the toxins that are present not in our body, but they come from outside.
Dioxin is a synthetic form with a super high affinity.
Yeah.
And it turns out that you get about half your lifetime burden of dioxin through nursing when you're a baby. And so you have it's extremely slow to non-existent metabolism. Mm-hmm. So it's a very toxic compound.
Yeah.
And it's one of the sentinel members of the PAS domain transcription factor family. The PAS, the P is per, the A is aren't, the partner of the aryl hydrocarbon receptor.
Yeah.
And SIM, single-minded.
Yeah.
Yeah.
So you're looking for which proteins that regulate transcription factors bind to these compounds and then activate transcription.
So what we were doing is we were looking for homologs.
Yeah.
And so I cloned the rat aryl hydrocarbon receptor probably in 94, 95, no.
Yeah.
Yeah. And then we realized that the genome was coming out, and there were all of these expressed sequence tags, ESTs, that were out there. And I was essentially interested in bioinformatic approaches to finding related molecules. And so the first one we found ended up being MOP1. So we named them all MOP, which was in retrospect a big mistake. MOP1 ended up being HIF1 alpha. MOP2 ended up being HIF2 alpha. MOP3 ended up being BMAL. MOP4 ended up being NPOS2.
Wow.
There was a list. We were I think at MOP11 by the time.
Wow. So those are all big players in physiology and metabolism,
right?
Because the HIFs actually sense hypoxia, or when our oxygen levels go down, they get activated. So there's a HIF1 and 2, and then
HIF3.
HIF3, and then MOF3 is now what is one of the clock components.
That's right.
And then NPAS2 is another clock component.
Yep.
Wow. So that was a very good harvest from the genome.
There was. We didn't know at the time exactly what they were doing.
Yeah.
So part of the most important part of my thesis wasn't necessarily cloning them. Mm-hmm. It was trying to figure out what exactly they did.
Yeah.
And so I ended up doing 2 hybrid screen.
Yeah.
where I took NPOS2
Yeah.
and I screened physical interactions with thousands and thousands of different fusions. And the molecule that came back ended up being BMAL or MOP3.
Yeah.
And so that's when I knew that they were partners. And then we had to figure out what element did they bind. And so we did another screen.
Yeah.
Genetics is wonderful because it can tell you what you don't already know.
Yeah. No, that was a beautiful paper in 1998.
Right.
That's essentially showed one of the critical components of circadian clock that's actually present in almost every single cell, and
If not every cell.
yeah,
Yeah, we haven't
almost every cell.
found any
Yeah,
that don't have some of them. Yeah.
yeah. And then you came to La Jolla. That's the time when you came to La Jolla.
Right.
And John is also very crucial in 3 similar papers or parallel papers that came out showing how circadian rhythms are very pervasive. They regulate transcription of many genes, turning on and off many genes in plants, Drosophila of fruit flies, and also in mice.
That's right.
Yeah. So can you tell us about the thought around that time? Because there was one camp, those are surprised that so many genes are regulated by clock, and then there was some other camp. I remember somebody commented, it's not surprising that so many genes are regulated by clock.
Right. I mean, I think our original estimates were on the order of 10%
Yeah.
of all genes were regulated by the clock.
Yeah.
And it wasn't until later when we started doing more and more tissues that we realized that collectively it was a much larger percentage, on the order of half the mouse genome was regulated by the clock. So in many ways, probably not surprising for a plant, but to think that half the human or mouse genome is regulated by the circadian system, I think did take people by surprise.
Yeah. I mean, in our baboon, we actually found nearly 85% of protein coding genes were rhythmic in a light dark cycle. And of course, these baboons were also getting meals within 8 hours window. But then the bottom line is, I think your work kind of paved the way for many other labs who have been doing this simple assay, looking at what time of the day or night genes turn on and off.
Right.
But I guess right now, although it might sound little self-promoting, but I guess from the circadian rhythm point of view, I would say, I think you'd agree that circadian rhythm is perhaps the only biological system that is known to regulate such a huge portion of the genome, because I cannot think of any other system, any other field of science, for example, autophagy or aging or any
The cell cycle, maybe.
the cell cycle. But I think even cell cycle, those components, do this regulate that huge 50-60% of the genome?
I don't really know the answer, and most of the cell cycle work has been in cell lines.
Yeah.
So where you're only going to express about a third to half of genes in a particular line. So I don't know that that's been done in a
Systematic manner, like the way circadian rhythm people do. So,
That's right.
Yeah. So I think that's very impressive. That looking back 20 years ago, we thought that maybe few dozen genes may be circadianly regulated. And now it's 80-85% of the genome, at least in one condition. Because what is also becoming clear is, for example, if you feed mice normal standard diet, there is a set of gene cycle, and then if you feed them a high-fat diet, a slightly separate set of genes.
Yeah, and then amplitudes go lower.
Yeah. So all these things.
Yeah.
So those are also very profound discoveries. And then I guess another profound discovery is to go back to timing of tissue collection and how human circadian rhythms could be deduced from some of the large-scale data, because that opened up.
Yeah, there's been just an explosion in literature just in the last 2 years. I think I stopped counting it, like a dozen papers looking in high-dimensional data for signs of rhythmicity.
Yeah.
And so that's been a huge area. And now we're now able to look in humans at the population scale for rhythmic regulation of all different organ systems, pretty much anything you can think of. You can now look at rhythmicity in people.
Yeah, and that is opening up real interest, because I think so far we were doing all these studies in mice, Drosophila, and in some cases non-human primates. But once you saw rhythms from real human samples, then clinicians pay attention. And I think one of the outcomes was this idea that 80 or 60% of the FDA-approved drug targets are now circadian?
I think about 50.
50?
And then of that 50%, about half have compounds that interact with them that have a short half-life.
Yeah.
So if you have a target that has a 48-hour half-life,
Yeah.
it's hard to imagine how the circadian system could really be influencing how it works.
Yeah.
But those short half-life drugs, those that have a half-life much less than 12 or 8 hours, it's kind of relatively straightforward to imagine how they might be influenced by when you actually take them.
Yeah.
So there's like optimal timing, which we can sort of infer from laboratory work. But when it comes down to it, there's really only 2 times a day that people are relatively adherent. And that is after they wake up in the morning and before they go to bed, are pretty much the only time you can count on people doing things. And even then, it's like 50 to 70%.
Yeah. But what percentage of the FDA-approved drugs actually have a long half-life? I mean, the point is...
About half.
About half.
Yeah.
Yeah. So that means for almost every disease you can think of,
there's at least one molecule that's interacting with a drug target metabolizing enzyme or transporter. For about half of all drugs, time could be relevant.
Yeah, and then if we look from the disease perspective, right now it would be accurate to say that nearly half of the adult population in the US are mild to moderate to severe hypertensive, right?
Higher. It depends on what age you are.
Yeah.
Once you get above 70 years old, it's a majority of people will develop hypertension.
Yeah, and then you had this paper, and then there are also many other now epidemiological data showing the relation between timing of hypertensive drug and there are 5 years adverse effect. The cardiac event.
Right.
So what's the jury out there?
Again, this it depends on the actual molecules, but the compounds that have a short half-life are probably relevant, and the ones, for example, that have a super long half-life, probably less relevant about when you take them. And there's another aspect of this that we haven't talked about yet, called non-dipping hypertension. This is where...
So let's go to that hypertension. And then, so blood pressure. Yeah. So what is hypertension and what is dipping and non-dipping?
Right. So hypertension is just your blood pressure being outside of the normal range.
Yeah.
And even over the course of working together over the last 20 years, the guidelines for hypertension have changed. So about 10 years ago, for example, you were considered hypertensive if your pressure was much higher than 130 over say 85 or 90. And then in the last 5 years, the guidelines have changed that you're now diagnosed with hypertension if you're much over 120. And so there's literally the majority of adults over age, say 70, will be on some blood pressure lowering medication, often more than one.
Yeah.
So for example, I'm on 2 different blood pressure lowering medications. One is metoprolol, and the second is Entresto. And so both of those compounds are used to treat, commonly used to treat hypertension and congestive heart failure. Yeah.
And then the dipping and non-dipping, what are those?
So non-dipping is when, so most people, your blood pressure changes throughout the day.
Yeah.
And so when you wake up, for example, your blood pressure starts to rise even before you're awakened.
Yeah.
And then there's a little bit of a peak as you're waking up. And then later in the day, it drops again. And then in about 1/3 of hypertensives, their blood pressure does not decrease while they're sleeping. So it stays high. And it turns out that epidemiologically, Large-scale studies conducted in Japan, the Ohasama trial, showed that if your pressure did not drop while you're sleeping, that your risk of a heart attack or stroke went up considerably, particularly in females, but it doubled even in males that are not normally dipping.
So that means if somebody has blood pressure, how can they know whether they're dippers or non-dippers?
Right. So this is the critical experiment. You do something called ambulatory blood pressure monitoring. So you wear a blood pressure cuff, the same kind of cuff that you use in your doctor's office.
Yeah.
And you simply there's a little tiny little box, and you pretty much hook it to your belt, and you wear it over a period of 1 or more days. Well, I've done it myself. I've done it over a 2-day period.
Yeah.
And it takes your pressure, say, once every 30 minutes during the expected daytime, and maybe once every hour at night. It'll inflate the cuff, take your pressure, and record it. So it's not the best night's sleep you'll ever have, but it's not something that you can't handle for a night or two.
Yeah.
And so that's how the formal diagnosis of non-dipping hypertension would be done. Actually, the formal diagnosis of hypertension in a major academic medical center would be this ambulatory blood pressure monitoring. And that's because a lot of people come to the doctor, and just going in the room with the doctor makes their blood pressure go up. They're called white coat hypertensives. They see a white coat and their blood pressure goes up.
Okay, coming back to ambulatory blood pressure monitoring, ABPM.
Yep.
Are these consumer grades? Can people buy them and wear, or are there consumer grade devices now they can use?
Yeah, so blood pressure has been a really tricky one to do both clinically and at home, and because the actual instrumentation has to be calibrated relatively often, and so while you can buy a cuff from Amazon, for example, $50, $100, you can buy a cuff. You can't really buy the ABPM cuffs commercially. They're not really they're not easy to purchase.
Yeah, but recently I saw there are some devices that claim to do blood pressure continuously, but I don't know the reliability. Any idea?
So they tend not to be as accurate as instruments that you'd use in a doctor's office, but they can give you some sense of blood pressure. Yeah, and it's probably good to monitor anyway, just because. For example, if you eat too much salt, that can cause hypertension, and it can be a good marker. Yeah. Having a day of hypertension, say your grant didn't get funded, which happened to me a couple of weeks ago. I definitely was high on my blood pressure was high that day or two.
No, so then coming back to the dipping, when does dipping start? Is it after getting into the bed or before? Because the point is, can some people, if it happens before, there is a trend, then people can actually measure before going to bed.
Right.
Does it happen before, or when is the lowest blood pressure? Is it in the middle of our sleep, or?
It's really around the middle of our sleep.
Wow. So there is no way one can actually see how much they're dipping
without ABPM.
Without ABPM.
Yeah.
I see. And then, as you said, the blood pressure begins to rise before you wake up. So by the time you wake up and get to your blood pressure monitor, it's already high.
You're already going to be high first thing in the morning.
Okay.
Yeah.
So it can. People who are curious and they can afford, can they ask their doctors to give them ABPM?
Probably. The answer is probably. Most academic medical centers, hospitals have these ABPM systems up, and if you go to a hypertension specialist, for sure you can get one, but it might not be something that your general practitioner that lives down the street probably does not have that.
And how much dipping happens for systolic? For example, somebody has a systolic of 130 or 140. Is dipping by 10 points, 15 points? What's the rule of thumb?
A rule of thumb would be 10%.
10%?
Yeah, 10%. So if you're typically 125 over 80, so dipping much below or above the 10% line.
10% of line. Yeah, okay. And then most of the blood pressure medications, many blood pressure medications target many different mechanisms, right? Different targets.
Yeah.
But only the ones that are short-acting. Do you know whether there are certain ones that are short-acting? Any?
Yeah. So, for example, I'm on metoprolol,
Yeah.
and
Is that a short-acting one?
that's a short-acting drug. And when I was prescribed it by my cardiologist, they even sent a note home with me to take this in the early evening hours.
Wow.
Yeah.
So it's actually coming down to practice.
It's reduced to practice.
Yeah.
And oftentimes, if you read the label, there'll even be some recommendations on when to take not very many, but a few medications. Yeah.
Okay. So
Sleep drugs is easy, right? You take those before you want to go to sleep.
no, it's the same thing. Like if people know that our heart should slow down and go to sleep, and blood pressure medication is essentially a sleep drug for the heart.
That's right. That's one way to think of it.
That's one way to think of it. So then why do you want to make your heart sleep in the late afternoon when you want to go for a walk or meet your friend? But in the evening, 2 to 3 hours before bedtime would be the ideal time to. And then what is the, do you remember what is the what is the increased hazard ratio if between morning and evening blood pressure medication?
I don't remember the exact values, but in the largest trial, which is a trial in Ohasama, Japan, about non-dipping females had almost a 4-fold increase in their likelihood of fourfold heart attack or stroke over the dipping hypertensives.
Yeah.
And the males had about a 2-fold higher risk of heart attack or stroke if they were non-dippers. Yeah. So
it's a big deal. It's not a 5% or 10% chance, but it's a big deal.
It's a big deal. You don't really even need epidemiological studies.
I see.
It's very common.
And if you're a non-dipper, then the medications do have to dip to bring that dip back, right?
You could do that.
Yeah.
People have that has not been done intentionally. At least people don't typically treat it clinically.
Yeah.
I would like to see that change and test the hypothesis that if we could reinstill dipping through pharmacology in a non-dipping population, could you actually increase lifespan?
Yeah.
Yeah, that would be the ideal thing.
Yeah.
One of the issues is there's not a lot of hypertension is considered a solved issue.
Yeah.
And there's not a lot of incentive for a drug company to test the ideas, and the numbers you'd need would also be quite large.
Yeah.
So you're looking at
got to monitor
for a long time.
for 5 years at least.
Right.
5 years mess. That's what they want to see.
Exactly.
Yeah. But the bottom line is whether you are dipper or non-dipper, at least taking the medication in the evening so that your heart can take some rest when you are sleeping.
Yeah, that's
the take-home message.
That's right. That's right.
Yeah.
And so certain medications which have long half-lives, it probably doesn't matter when you take them.
Yeah.
But there are many short-acting antihypertensives.
Yeah.
And they're taking them prior to bed is probably a good idea.
Yeah. Then the next, after hypertension, the next one, many people over the age of 40 or 45 are on statins.
Yes.
Is there any circadian timing of statins that are?
There is, and the same rule applies. If the statin is a short-acting statin, then you're advised to take them prior to bed.
I see.
Whereas if it's a long-acting statin, again, it probably doesn't really matter.
Yeah.
When you take it, I'm on a statin, and I'm supposed to take it prior to going to sleep. But a lot of these adherence to protocol is relatively poor. I'm pretty good about it. I have a pill box.
Yeah.
Monday through Sunday.
Yeah, Monday through Sunday. Yeah.
Yeah, and then there's a morning side and an evening side.
Yeah.
And I actually don't feel very good if I skip metoprolol, which is one of the drugs I'm on. It's an antihypertensive. And so I'm pretty good about taking it just because I don't want to be nervous.
Yeah.
Metoprolol can also make you feel a little less nervous.
Yeah.
Yeah.
No, I guess that's the simple thing people can do when they are on any medication. It's better to buy those Monday through Sunday with dual AM and PM or morning and evening.
Right.
And that's the best way to track.
Yeah.
I mean, there are also many apps and other stuff, but then if you have it next to your
Yeah, right.
kitchen or in the bedside, that's the
I
best.
keep mine in the kitchen.
Yeah,
Yeah.
that's what I also do for my vitamins and supplements. Yeah, so statins are also like that. And then, I mean, when it comes to blood sugar, I guess nowadays there are a lot of long-acting drugs from GLP-1
Right.
onwards. So then when you're taking it once a day or once a week, then those may not matter.
It probably doesn't matter for the very long-acting molecules. Yeah.
But once people get sick and get to the hospital, before I move away from this topic, also wanted to know, since certain drugs can have benefits only when, or increased benefits when they're taken at the right time, one example that comes up that we often cite are the cancer drugs.
Yeah. So chemotherapeutic agents
Yeah.
are often brought up. Many of the prospective trials are limited by sample number, the number of people that were in a particular trial. There's a famous physician, Francis Levy,
Yeah.
who's done a number of the chemotherapy studies looking at timing of chemotherapy agents, and they have shown different effectiveness, sometimes differing based on what sex a person is, male or female. They'll perform differently when taken at different times of the day. The details of why and how this works aren't super clear, but the observations are there.
Yeah.
Yeah.
And then there was this story about platin, oxaliplatin.
Right.
What's the story?
So this is one of the drugs
Yeah.
that Dr. Levy has been studying, and so I forget the exact details, but I think the effect is stronger in females than in males.
I see. Okay. Yeah.
So
that's it.
the efficacy of the drug was better
Yeah.
in one of the two sexes.
Yeah.
Yeah.
Yeah. So when they get to the hospital,
Yeah.
what happens in the hospital?
Yeah. So you'll come in, and there'll be a reason why you came in. You'll come into the hospital, and you'll be seen by a physician. Possibly you'll be admitted. For example, a couple of years ago, I was admitted, and I had a heart surgery. And then a care team will go bed by bed and sort of assess your vital markers and make medical decisions, which could involve medication or procedures or even psychological testing. They'll prescribe those interventions, and then one of the really interesting thing about hospital medicine is that pretty much everything that's done in a hospital, someone writes down the time in which they did it.
Yeah.
And so it's a super large data sets.
Also with the electronic health record,
Everything's documented. Yes. And while the motivation may be billing, it still can be used for research purposes.
No, actually, one of the HIPAA law is all the entries have to be time-stamped, and who wrote it also goes there. Which device or which physician or nurse, that's one of the HIPAA.
Right. This was a tricky part when we started doing this stuff, is people considered the time of day as being possibly identifiable. And so when we did some of our studies, we had to instead of using a day of the year, March 28th, for example, we had to abstract everything to a randomly chosen date.
Oh.
And so that nobody could be possibly identified by the date in which they were in the hospital.
Yeah. So then what did you find?
Well, we found that virtually all drugs given in the hospital are given in a rhythmic fashion. We can't say circadian because we have the light-dark cycle and food and other entraining cues, but almost everything that's done in a hospital is done in a rhythmic fashion.
Yeah.
And that includes dosing of medications, procedures, all done in a rhythmic fashion.
So when you so are all done, for example, most medications given in the morning, noon, or evening? Did you find something?
There's two bursts.
Yeah.
The first burst is after morning rounding. Rounding is where the care team goes bed by bed. And so most drugs, probably, more than 70% are given right after the morning rounding phase. And then there's a second rounding period later in the day. At our hospital, it's between 4 and 6 p.m. And so we saw another burst of orders occurring at 4 or 6 p.m. and then the medication given with about an hour delay.
I see. Are there certain drugs that you found were given at the wrong time? Like, for example, melatonin in the morning? No, actually, no.
We didn't look specifically for melatonin.
No, I was just kidding. But are there mistimed drugs?
Yes, for sure.
Yeah.
One of the interesting cases is pain medications. So people complain most about pain at night.
Yeah.
And we noticed that very strong pain medications like morphine are actually commonly prescribed in the morning. And so there's an example of it being potentially mistimed.
Yeah.
A second example is vancomycin, which is the last line antibiotic.
Yeah.
It's used to treat things like infection. And we also saw the morning peak of vancomycin orders, but you should really get an anti-infective when you have an infection, not just because the rounding was between 7 a.m. and 9 a.m. in the morning.
So there is scope for optimizing hospital practice.
That's right. There's an impetus for optimizing dosage of certain medications to keep people out of pain and to make sure their infections are treated expeditiously.
So in hospitals, so now the medications and care, and also the diagnosis and, like you said, the rounding happen at certain time. Those are the practices. But then people are stuck in these hospitals where in many cases, I won't say in all cases, the light is also constant, right? Which is non-circadian.
It can be.
I mean, we can use the word circadian for rhythmic in this context.
Right. Yeah. So oftentimes the windows are not optimal, so you don't really get exposure to natural light. I was in a room at a hospital in Cincinnati, and one of the rooms I was in didn't have any windows at all.
Yeah.
So it was the same, mostly bluish white light that was relatively dim that I was exposed to at pretty much not 24/7, but for large chunks of the day. And so this not the best night's sleep you'll ever have when lights are on.
And you're also sick at that time.
Yep, you're sick, and there's many monitoring devices also in the room with you.
Yeah.
And some of them have really
beep.
They make noise, that's for sure, but they also have these LEDs.
Yeah.
And they're surprisingly bright, shockingly bright in some cases. And so those can also interfere with sleep.
So I guess the take-home message is, if somebody is going to hospital, if your loved one is going to hospital, I'm sorry, unfortunately, then they can at least bring an eye mask and earplugs.
An eye mask is an excellent idea. I just sent one to one of our oncologists at Children's, a recommendation for one to help patients sleep in the hospital.
Yeah.
And earplugs are also a good idea. A lot of the instrumentation does make noise, and the care staff coming in and out of the room can also wake you.
Yeah. No, actually, my bag always have 2 or 3 eye masks and a pack of earplugs. Actually, there is, you can buy them like 100 earplugs for $5 or $10. It's pretty cheap when you buy them in bulk.
Right.
And in fact, in one of our clinical trials for firefighters, we gave them earplugs and eye masks. And they're super excited because sometimes they're catching a little bit of sleep in a car somewhere parked, because during the day, of course, when they're working, they don't use them. But they come back in the morning after overnight shift,
right.
And then they're taking their kids to drop in the school, and then they have 1 hour somewhere. They don't have time to come back home for a nap.
Right.
They just put that eye mask and earplugs and sleep in the car. And I was surprised at how. And then I was thinking, well, in all ICUs and in hospitals, just like, 1 day of hospital stay is several $1,000s, right? And if you're flying business class, that's also a few $1,000s. But at least in business class, you get a eye mask and earplugs.
Unfortunately, most of the time I'm not flying business class.
No, I'm saying that a hospital room is more expensive than a business class
Oh,
flight.
for sure.
And at least they should give you a earplugs and eye mask.
You'd think. You'd think.
Yeah. So the lights are on. And then the other thing that we all organisms, including humans, our metabolism is circadian or goes in a rhythmic fashion. So what is the hospital practice? Because most people who are on solid food, they can eat solid food. Usually the hospitals bring breakfast, lunch, and dinner, and those are delivered at the specific time, roughly corresponding to somewhere between, say, 7 to 9 a.m. in the morning, and then lunch somewhere around noon, and then evening.
Correct.
But then those who are seriously sick, they do get this who cannot eat. Or
Right.
so what happens there?
So in many cases, they'll get either enteral or parenteral feeding.
What is enteral and what is parenteral?
Of feeding directly to the stomach.
Yeah, is enteral.
Yeah, enteral. Yeah. And then parenteral is where you have typically a central line.
Yeah.
Where you'll get all of your calories, your vitamins, your minerals, your hydration will all come in in an IV. That's a bag that's near your bed.
Yeah.
And in many cases, feeding is done 24/7. So instead of having breakfast, lunch, and dinner, they'll be fed continuously. And so inspired by your work on time-restricted feeding, we decided to see if we could challenge the paradigm of 24/7 feeding, which we know is bad even for healthy undergraduates to do for a period of time. So we decided to essentially make a concentrated form of nutrition and administer it over a 12-hour period. And the patients that got the 12-hour feeding recovered at least 5 days sooner than the patients that got the 24-hour feeding, which again is standard of practice.
So 5 days sooner.
Yeah.
And what kind of patients are these?
These are bone marrow transplant patients.
Yeah.
So these are typically, they have either a hematopoietic disorder or possibly even cancer.
Yeah.
And so they've gone through a cycle of radiation and chemotherapy. And then because of this, the cells in their gut don't work. And so even if you were to feed them orally, the nutrition is actually not assimilated efficiently. So you have to give this total parenteral nutrition to ensure they have the right number of calories. We're at a pediatric hospital, so it's particularly tricky amongst kids, where they can literally be 10 or 20 pounds and another kid could be 200 pounds.
Yeah.
So getting all the calorie requirements filled is tricky.
Yeah. And how many patients in the US or in your hospital, for example, go through this TPN, total parental nutrition?
So we probably have a few hundred in a given year, and then all in America, there's about.
That's only one hospital in one.
Right, in one city. Yeah, there's probably about 4,000 to 5,000 bone marrow transplants just in the United States done every year.
Yeah,
and so it's literally thousands of people are
going through this,
being fed 24/7.
Yeah,
and as your work has shown, probably not a good idea.
Yeah, but in terms of societal health, the personal health, and also, as you mentioned, it's being in a hospital is not the happiest thing.
No,
you are trying to get out of the hospital, and also your family members are anxious to get you out of the hospital, come home, and it costs money, even for the insurers.
Absolutely,
it's at least $10,000 a night.
Correct.
So just giving.
We're talking Waldorf Astoria hotel prices, and the TV doesn't even work very well.
Yeah.
The food's not great. Yeah. Actually, when I was in addition to regulating the time I could eat, what I could eat was actually also regulated. So I tried to order a sandwich and was told that I could not have the sandwich. I could have a plate of fruit instead.
Not fresh fruit, maybe. So the bottom line is, means there is no other medical practice that we know of, or that's in a clinical trial, phase 1 or phase 2, that will make these people who are getting TPN and bone marrow transplant or bone marrow transplant to get out of the hospital 4 to 5 days earlier. There is nothing, because even if you go back to the peak of COVID, the medication that got approved that did not save life, it actually accelerated, it actually helped people to get out of the hospital
To recover, yeah.
recover 4 to 5 days earlier
Right.
than those who did not get the medication.
That's right.
So in that context, it's very similar to, if we compare that, this 12 hours feeding in this case
Right.
is equivalent to having a medication that can get you out of the hospital 5 days earlier.
And it's implementable.
And it's implementable. It's, as you showed, it does not need FDA approval.
Nope.
It just needs some thinking and some bold step from. So was it easy to implement?
It was not. And it probably took a couple of years.
Couple of years?
Yeah.
Wow.
And the hardest part of it was the nutritionist, who's an amazing scientist in their own right, had to figure out how to concentrate the food. And so that was the limitation.
Yeah.
And at the beginning, this particular nutritionist was wholeheartedly against concentrating the food. They were concerned that some of it would come out of solution and not be absorbed.
Yeah.
And over time, as we sort of made progress, eventually they came on board, and now they're probably the strongest proponent of time-restricted feeding, is the person who was against it before.
And then this study had 20 participants, right?
Right.
So is there a plan to expand it to?
Yes. Yes. We're writing for support to the NIH to expand to about 60 to 80 patients. And then ultimately, what we'd like to do is go multi-site clinical trials, where we apply the same time-restricted feeding across multiple hospital systems, multiple sets of patients with different diagnoses, and really drive this home.
Yeah.
Yeah. It could be that the most useful thing I ever did medically was talk to my colleagues at the hospital. Forget the BMAL, nobody cares about that. But this may actually be implementable and really help people.
No, I totally agree with that, because I remember the first time when Pam Taub, who is my collaborator, cardiologist, we started this time-restricted feeding study with people with metabolic syndrome. And we had only 20 patients, 19 patients actually completed the study. But after the 4th or 5th patient, she was super excited. And then I said, you treat patients all the time. Why are you so excited? And she said, when we write a prescription, the next time when the patient comes back, there are 2 outcomes. One, the patient actually took the medication, and they will come back and complain about the adverse side effects. And then there is another outcome, that is, they didn't take the medication and nothing changed. And here they're coming back they are feeling much better, more energetic, they're happier, and there is no adverse side effect. So I remember that day that I felt like, yes, whatever I have done in basic science doesn't matter. When somebody comes back and says it improved their health, even if that's one person, 5 people or 10 people,
it's inspiring.
That's inspiring.
It's inspiring even for basic researchers that get excited about genes and how they work in a cell or in an organ system. To get a note from a parent or to get a note from a patient and say that they are feeling better and they've recovered or something has gone well for them really helps frame your day. Yeah. So worrying about NIH grant scores doesn't have the same pull as getting a note from a parent that says that their child slept through the night for the first time in 18 years.
Yeah.
Yeah.
So this will be really exciting to see this practice, because once hospital practices are set in stone almost, and it's really hard to change.
It's hard to change the culture of the
culture.
of the hospital.
Yeah, but once you change, the good thing is once you change, that's also set in stone. That practice becomes a standard of care.
Right.
So it'll be really exciting to see at least in 10 years.
Yeah, what's going to
Can we
happen?
have at least 10 hospitals change their practice?
Right.
And then that will be really a huge contribution to the field, from circadian rhythm field to directly to healthcare.
Or even lighting. I haven't
So
mentioned
coming
this.
back to the lighting.
I haven't really mentioned this, but we just opened a new critical care center at Cincinnati Children's Hospital, and two of our researchers, Richard Lang and his colleagues, have installed a lighting system that's capable of simulating outdoor light, the different spectra of light and the intensity of light that you'd see, for example, in the shade on a sunny day.
Yeah.
And typically, when you go into any room indoors, you're getting a lot less light than you would outside.
Yeah.
And we know that constant dim light it is detrimental to health.
Yeah.
And getting the light correct, getting the timing of food correct, getting the duration of food correct. These are all implementable interventions that could end up being very beneficial to parents, to children, even to caregivers.
Yeah. No, I guess we have to say that these are much more powerful than some medications, because there is no medication that we know of that will accelerate cure and get these people out of ICU or out of hospitals days and sometimes even weeks. For example, this NICU study that you mentioned.
Yeah.
Yeah. So can you tell a little bit about this?
Well, this is interesting. My first encounter with the NICU was when my eldest son Eli was born here at UCSD hospital.
Yeah.
So he was born there, and about maybe 20 minutes after he was born, he stopped breathing. It turned out his airway was obstructed. And so we hit the button on the wall, and a whole bunch of people come in. There was probably 10 people that came into the room, and they shuttled him off to the NICU.
Yeah.
And I went down to go see him to make sure he was doing okay. And I walk in the room, and it's the middle of the day, and it was probably one of the darkest rooms I've ever been in. All the lights were off.
Yeah.
And even the incubators, the hospital beds for the infants, they had towels over them. So even what little light was in the room, there was even less light. And this is in the middle of the day.
Yeah.
And knowing about your work and several of our colleagues in the circadian field, and realizing that in the wild, when we evolved, we have much brighter light and full spectrum light.
Yeah.
It occurred to me this was really kind of crazy, and again a cultural practice.
Yeah.
Nothing to do with science or medicine.
Yeah.
But just the way that things started, and it's kind of hard to change things once you start.
And then so the lighting remained that dim throughout 24/7.
24/7 dim light.
Yeah.
And the nursing staff, pretty much everyone is convinced that infants need very quiet, dim light.
Yeah.
And to be honest, there aren't really high quality studies that demonstrate that that's the case.
No, it's also very difficult to do studies on infants because of liabilities. So anything that goes wrong, people can potentially link it to the change in practice. That's what I have learned, because I also tried to do similar study simulating bright light, dim light cycles in NICU, and that was the biggest challenge. If anything goes wrong that may be unrelated to what you're doing, that can potentially be linked to this what you're trying to intervention.
Yeah.
And this is also becoming more and more important, because right now in the US, nearly 10% of babies are born premature, but again, even if the baby is not born premature, as in this case, your son, they end up in NICU for a few days. So we're talking about 1 in 10 or 1 in 9 babies born in the US right now are spending few days in NICU.
Right. Right, which is a considerable number.
Yeah, which is around 380,000 babies every year. 380,000 babies are staying in NICU. And if we can reduce their hospital stay, some of the studies are showing almost 2 weeks. Some are 7 days. Some studies are showing up to 13 days. That's a huge amount of saving. And also, when I didn't know that your son was actually in NICU, and it must be heart-wrenching to see your baby in.
It was not my favorite. It's probably the worst day of my life.
Yeah.
Where you realize that you love this person and they're hanging on by a thread.
Yeah. And you want that person to
do well, get out.
Get out of that place.
That's right.
Yeah. Yeah. So this is also another simple practice that can.
Simple, implementable.
Yeah.
You've brought up the potential legal issues. At the same time, it's hard to argue that over the course of evolution, that we never really were exposed to dim light all the time. In fact, it's a type of environment that if you were to experience it yourself, you probably not like it.
Yeah.
But we do it to babies because there is no good reason that we just do it.
Well, they cannot complain.
They complain by crying.
They complain by crying, but we think that they're hungry and then we feed them or do something.
Right.
Yeah.
In fact, when they did some of these studies and they used crying as a readout, the infants that had better cycling lights cried less than the infants that were.
Oh, that's very important. Actually, for parents, the less crying is such a huge issue.
Yes.
Yeah.
Yes.
Because when they cry, you have no idea why they're crying, whether there is tummy ache or
their diaper needs to be changed or what have you.
Yeah. So hopefully they were not crying, but their diaper was not wet.
Right. Speaking of that, may I take a quick break?
Sure.
Yeah.
Yeah.
I think these interventions that are implementable are very important, not just for the benefit of patients, but also for our field.
Yeah.
For our field to really move forward, we need a better understanding that we're not meant to be in constant dim light 24 hours a day, 7 days a week.
Yeah.
We're not meant to be fed 24 hours a day, 7 days a week.
Yeah.
We didn't evolve that way.
Yeah.
And really, lighting has changed fundamentally over the last 100 years.
Yeah, I mean, if you look at lighting, initially lighting was to light up the evening, make us feel safe, and also give us lighting so that we can be engaged in some activities, whether it's family activity or something else. But I guess in the last 20 years, after the discovery of melanopsin and the quality of light, how it affects our circadian rhythm and how circadian rhythm disruption is so pervasive, it's almost, I call that we are living in the time of lead and asbestos, because this is an inflection point. We built, like I say, we built a lot of buildings with lead and asbestos until we figured out that, this is actually bad.
Right.
Then it's taking us a generation to clean up the building.
To mitigate the problem, yeah.
Same thing with smoking. Initially we thought, smoking is harmless. And then
or even good for you.
Good for you. Yeah. And now it's taking almost a generation to change that.
Right.
So I guess we are in that inflection point where we're just learning how bad are some of these practices that we took for granted. And it might take a generation, but hopefully if we are more active and we do the right studies, then it may take half a generation.
Right. That's what gets you excited about being a scientist and focusing on problems, is thinking that what you do could influence how people live and thrive.
Yeah. So I mean, I always say performance, that to live at our peak or optimum performance, whether it's physical, intellectual, or emotional performance, irrespective of age, sex, health condition, means even a 100-year-old also is thriving, is wanting to be at optimum performance. It's kind of a universal human right and aspiration. And
Absolutely. I think about college athletes.
yeah,
For example, USC and UCLA have joined the Big Ten.
yeah,
And they'll now be flying clear across the country, for example, to play Rutgers or to go play Michigan. And they're moving over multiple time zones. And we know, like, if anyone who's traveled realizes that it takes several days for you to acclimate.
yeah. So actually, you and many other leaders in the field wrote this opinion piece in JBR.
Right.
So can you tell us a little bit more about that? Like, it's really a very burning issue. It's very hot topic because these kids, they have to study and they also have to play.
That's correct.
So can you tell us, like, how many games they have to play, for how many games they have to actually travel?
It depends on the sport.
Yeah.
For example, in college football, which is really how the genesis of the paper, you only have about between 10 and 12 games per year, depending on how far you advance.
Yeah.
And half the games, more or less, are road games.
Yeah.
So it really would displace up to 80 or 90 individuals who are traveling with the team over say 4 to 6 weeks a year. So not a ton of people. Take other sports like college basketball, men's or women's. But now instead of having 10 to 12 games per year, they'd have 30 to 40 games per year. So it's going to be a much more disruptive period of time. And so getting the conditions correct for optimal athletic performance probably means that these professional and collegiate teams need people like you or like me to advise on the best way to acclimate to your local time zone. Probably the best way to acclimate your behavioral rhythms, but also things like feeding, things like hydration. How do you acclimate and perform at your best?
Yeah.
Yeah, I think about the athletes in Hawaii, and so I noticed that one of the teams, University of Hawaii, is traveling to Nashville this past season.
Yeah.
So that's really being temporarily displaced over 5 times. It's the equivalent of flying to Europe on the East Coast. Yeah.
And then they're flying how many days before the game?
It depends. And sometimes they do smart things, like if they're going to travel, they'll play multiple games over. For example, in college basketball, they may make an East Coast trip and spend a few days on the East Coast, which is pretty smart.
Yeah.
But for games like football, where you play them basically on a weekly basis, they fly back and forth.
Yeah.
Yeah.
So actually, in terms of professional sports, particularly, what I call stick and balls, that involves a stick or a ball or a combination of both. Those sports all over the world, now that there are many of these sports being played and people are traveling, it has huge impact on the athletes' health also.
Right.
Means many athletes may not be performing at their peak because of the circadian disruption. And second is they may not be, their strength or their physical endurance may be okay, but then when it comes to the brain talking to the muscle to move in the right direction at the right time, in the right speed, etc., then even a small mistake there is the difference between winning and losing.
It could be the difference between winning and losing. There's a lot of people that have looked at performance in certain sports, like baseball.
Yeah.
And they have noticed that the teams that are mostly traveling east, so getting light earlier in the day, tend to do worse than the teams that are traveling the opposite direction, out west.
Oh, okay. It also depends on what time of the day the game is being played, but most games are mostly in the afternoon or evening.
Right.
Except cricket. India that's played throughout the day.
Was it the cricket championships were over the last month or two, right?
Yeah, so now cricket is means there is also the half day cricket or limited overs, so those are day night. But traditionally the classic 5 days cricket is over 5 days or 7 days.
And if you look at the teams that are really competitive in cricket,
Yeah,
India, Australia, England,
Yeah.
they're over even more time zones than the East Coast and West Coast of the United States. There's a huge temporal displacement.
yeah. I mean, those are. Means the nice thing about cricket is not everybody is means the batsmen come in and then bat and then go back, and then the bowlers are also doing. But some sports like Formula One racing, those guys, if you look at their calendar now, they are traveling in almost every 4 to 5 weeks. They're in a different city around the world. And for them, a tiny mistake is life or death,
Right.
or a big car going out in flames.
I can't even watch it when the cameras are inside the Formula One vehicles. It's too fast for me. It makes me nervous.
Yeah.
Even watching it on TV makes me nervous.
So I guess there is a lot of opportunity for our field to contribute, starting from extremely sick patients, from NICU or ICU, to even extremely high-performing athletes, Formula One drivers or college basketball players, college athletes. And now that this year Olympics will be played, this is the right time to think about how circadian rhythm or its disruption has a huge impact on athletic performance.
Right. I've been trying to couch the movement to a better understanding as a concept in circadian medicine.
Yeah.
How can we apply what we've learned in the lab over the last several decades? How can we apply it to help people not just recover quicker from sickness, but also perform better?
Yeah. I mean, one thing is circadian rhythm concepts can be used to prevent disease from happening. And once the disease happens, can we accelerate prognosis so that people can get better faster? And then the third step is return to play. Can they come back to full functionality, full performance, optimum performance much faster? Those are the three aspects.
It's hard to think of another area of science that has such a profound effect on both health and performance.
Yeah.
As the system, the circadian system. It's really hard to imagine. Maybe the cell cycle would be the only other field where you can think about that type of societal benefit.
Yeah. But again, cell cycle, for example, I don't know how much of that impacts heart health.
Right.
Or
hypertension. I don't know either.
Right?
Yeah.
There is not much. So coming back to the last topic, like you are going to be the president of SRBR, what are your visions for a few things? One is training the next generation of circadian biologists. Second is bringing established investigators in other fields of biology or medicine into our field. And third, as you said, how to disseminate the knowledge that we already have to...
Exactly. One of the initiatives we've organized for this year's conference is having a circadian medicine day prior to the start of the Society for Research on Biological Rhythms.
Yeah.
And so we're bringing in physicians from across the country and also caregivers from across the country to actually participate in a day of learning about how to actually restore, in many cases, restore normal rhythmicity to a patient, either with feeding patterns or with sleep,
or lighting,
et cetera.
Yeah.
So that'll be occurring this summer for the first time. So long term, I hope this becomes a standing feature of SRBR, that there's additional focus on implementable changes we can do to help people.
Yeah. And then what about training the next generation?
Yeah, so it's really remarkable, but we're offering this course to trainees. Really, people from any career stage are welcome to attend the conference, and they'll get continuing medical education credits. So it will count towards their licensure, for example, in California or Alabama or wherever they're from. They'll get credit for attending this session.
Cool. Now, this is exciting, and we are really lucky to have you as the next SRBR president. And this is an exciting time in research and translation, and hope to talk to you again in a couple of years to review some of these clinical trials that will hopefully start in many different parts of the country and maybe even different parts of the world, and see how we can move this big ship, this human health, in the right direction with finding.
It's an exciting time to be working.
Yeah. Thank you so much.
Of course. Thanks for having me.
Thank you.
Ciao, ciao.
Ciao.